Hi, AP Stat students. We are going to talk about a 2-sample Z interval for P1 minus P2 and a 2-sample Z test for P1 minus P2. So let's begin. I should rewind real quick. Before we begin, I want to make sure that you did indeed watch the video from yesterday. That's really imperative to watch that one. That kind of sets up the rest of our significance test, right? With that state, plan, do, conclude. It talks about those conditions, the RIN, and that's super important. I'm not going to talk about that as much in this one. It also talks about the interpretation of the p-value and the confidence level. So that's very vital. So please, please, please make sure that you check that out before you watch this one. And it is long. And I'm going to try to keep this one a little bit shorter than yesterday, although I'm talking about two different things. So it's going to take a tiny bit. So take some breaks when needed, but make sure you get through this whole video. So with that being said, let's begin. High levels of cholesterol in blood are associated with higher risk of heart attacks. Will using a drug to lower blood cholesterol reduce heart attacks? The Helsinki Heart Study looked at this question. Middle-aged men were assigned at random to one of the two treatments. 2,051 men took the drug gemfibrozil to reduce their blood cholesterol levels, and a control group of 2,030 men took a placebo. During the next 5 years, 56 men in the gemfibrozil group and 84 men in the placebo group had heart attacks. Okay, so the goal today is just to review with you how to do that 2-sample Z interval and that 2-sample Z test. And so I'm going to do that through this problem. So let's start with the 99% confidence interval. For the state, I want you to think about it in your head. What do you need first? And what you need first is you need the parameters. There's two parameters here, okay? So we're talking about people who took, or the proportion of people who took gemfibrozil and had heart attacks after 5 years, and then the proportion of people who had heart attacks after taking that placebo. Okay. Now, what's important to note too, that this is an experiment, and that's important because it changes things just a little bit. So we'll talk about that right now. So here I have the first two ones. So before you write it down, let's read through it, let's read through it, talk through some of the issues, and go from there. So P1 I set up for gemfibrozil. I did that because I read that first, and the question doesn't say anything about why gemfibrozil minus the placebo or vice versa, okay? I also think it's important to note, and I talked about this yesterday, some people say, how do I know to do a confidence interval versus a test? It states, find a confidence interval when you're doing a confidence interval. If it doesn't, you're doing a test. And typically, it doesn't say do a test. Typically, it will say, do we have evidence for? Use alpha equal to 0.01. Okay. All right. So P1, the true proportion of men who took gemfibrozil and had heart attacks after 5 years. Now, what do you notice? I left this part out. You need to put in like the ones in the study, somewhere in there, because this wasn't a random sample of all men. These were volunteers in a study, okay? And so that's important to note. You have to state something about like the ones in the study. P2, the true proportion of men, like the ones in the study, who took the placebo and had a heart attack after 5 years. State. The plan, okay? With a 2-sample, you need to RIN twice. Now, this is an experiment, so we do need to talk about it a little differently. I do think it's important to note, though, I want you just to envision if it wasn't an experiment. Let's say I was looking at the proportion of 9th graders who like cheese pizza versus the proportion of 10th graders that like cheese pizza. We would RIN twice. So if you remember in class, I made this little, I called it, I think, a little graphic or bubble map or whatever you want to call it, okay? And I had arrows going out, and that was to remind you have to do it twice when there's 2 samples. So you'd say we'd have a random sample, and now I'm making this up with a different story just to remind you. We have a random sample. The independence would still be the same. You do that twice, and the NP is still the same. And now, again, I put the P hat there. Why? I put the P hat there because it is indeed it's an interval, and we don't know the parameter. Sorry, my daughter's outside, so sometimes they'll catch me looking outside, just making sure she's okay. Okay, so let's go back. This would be if it was a regular observational study where we're just observing things. There's no random treatment. We're just surveying people and getting their thoughts about how they like cheese pizza when I'm talking about this problem. Let's go back to the actual experiment. Okay, so how do I know this is an experiment? That's a question that will pop up. We know it's an experiment because treatments are randomly assigned. A treatment is imposed. So how does that affect our random and our independence? If you remember from class, the R and the I have to go together. So what we say is we say random assignment of treatments, so groups are independent, as well as I and D, individual responses are also independent, okay? I should have written out individual here. I'm worried someone might think that's individual or independent and it's individuals, okay? So let's read it again. Random assignment of treatments. So groups are independent as well as individual responses are independent. Next, we have the N, okay? The N, we're still doing our N times P for both groups. Now, to save us some time, I only did it for the jump fibrosol group. So N times P hat is greater than or equal to 10. And then N times 1 minus P hat is greater than or equal to 10, okay? And then you would have to do it again for that placebo group. I'm going to skip that right now just to save us some time. You guys have been busy watching a lot of videos. Okay. Next, we have the state, we have the plan. In the plan, we need a method, okay? So we just rinned, we've checked our conditions. Now we can use a method, and that is going to be the 2-sample Z interval for P1 minus P2. We're on to the do. Okay. Now, what I need you to do, okay, so now we're at the do part. We are at the do part. We need our formula sheet for this. On the task, you really want to utilize this formula sheet, become one with this formula sheet. I look here and I see this confidence interval, okay? I have my statistic. So I'm going to go back now to my slide, and that's this right here. I actually have 2 statistics, right? I have the part over the total for the jump fibrosol group, and you can see that up here, okay? 56 men of the jump fibrosol group had a heart attack versus 84 in the placebo group. So 56 out of 2,051, and we have another statistic that 84 out of 2,030. We have 2 statistics. We're interested in the difference of them. I am going to put a little parentheses here around that. Okay. Then let's go back to our formula sheet. Plus or minus the critical value. Now we're doing a 99% confidence interval. So I'm going to go where my critical values are. And that's right here in table B. I go to that where it says infinity here. I go to 99%, go up 2.576. That's where this value comes from. Next, I need my standard deviation. Okay. And you can see that right here on the formula sheets. Times the standard deviation of the statistic. So I have 2 samples. I am dealing with a proportion, and the top one is for the interval and the bottom one is for a test. Okay. We're doing an interval. So you take the statistic, not the parameter, because we don't know the parameter, times 1 minus the statistic for the first group. So in our case, it'd be the jump fibrosol group. And then the statistic for the placebo group, times 1 minus the statistic all over the sample size for the placebo group. I'm going to go and I'm going to look at that. So I did that right there. I have my Z star. I have my statistic for the jump fibrosol group, which is right there as well, times 1 minus that. And then again for the placebo, all over their sample sizes and a square root. Now, if you don't have a calculator, you unfortunately are going to have to do this by hand, okay? But if you do have a calculator, okay, and if you don't have a calculator, you should reach out to me because I can see maybe I can get some school ones for you guys on the day of the test. I'm not certain if I'll be able to, but I'll look into it for sure. Okay, so I'm going to go to stat. I am going to go over to tests. I am going to go to 2 prop Z interval. Not 2 sample, 2 prop. I'm going to hit enter, and you can see I have my stuff already marked in. So this is the part of the jump fibrosol group out of a total sample part out of a total sample for placebo, 0.99. Enter, and there you go. So the big thing is when you write down that interval there, okay, so that's negative 0.0288, right? Comma, be really careful. Do not put 6.07. You need to make sure that's scientific notation. So move the decimal back 4 places. So that's 0.0006. Okay. And so now I am 99% confident that the interval from negative 0.0288 to 0.0006 contains the true difference in the proportion of men, like the ones in the study, who had heart attacks after 5 years in the gemfibrozil group versus the placebo group. Okay. Okay, so now where we are at is just the follow-up questions that might come, and one might be, so part C would be find the interval. Part D would be, do you have evidence that there's a difference? Now, what you should notice here is our interval is negative and then positive, which means 0 is included in the interval. This is a lower bound and an upper bound that contains plausible values for the truth. Since 0 is in my 99% confidence interval, I have, it could be the same, right? So I don't have any evidence that there's a difference, and that's what you would put. Okay, next and finally, so I can get outside with my daughter, is we have our significance test, okay? Is there a significant difference between the heart attack rate of those who took gemfibrozil and the rate of those who received the placebo? Test the appropriate hypothesis at the 1% significance level. So what's different about this state? You still need the parameters, which we have over here, okay? Parameter describing the whole population. We also need a null hypothesis, an alternative hypothesis, and a sigma, okay? That's your alpha level. That's your significance level. So with your null hypothesis, that's always P1 is equal to P2. Always, 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 okay? You always assume that the proportions are the same. In this case, they're asking, is there a difference? They don't say is the gemfibrozil proportion lower or greater than. They don't give you any words that would tell you you have to have some sort of inequality. So you say it is not equal to. I am not going to retype the P1 and P2 because I talked about it. There's no need, and I'm trying to save you guys a little bit of time. Plan is the exact same, okay? You RIN just like you do over here. Because it's an experiment, we write it like that. If it was not an experiment, it would be your normal RIN. And again, just don't forget about that third arrow there with that normal RIN. I'm not certain I talked about it when I talked about it previously. That's where you have to say the groups are independent of each other. Okay, so sorry, just paused it. We have our state, we have our P1 or P2, we have our null hypothesis and our alternative. I just talked about RIN. We need to RIN twice. Okay, but in this case, because it's an experiment, we do it just like we did over here. And I just talked about what happens previously, right? If it is just an observational study like normal, if it's not an experiment. How do I know it's an experiment? The question I get asked all the time, you would have a random treatment assigned. Okay, so I'm going to skip the RIN part and I'm going to go right to the method. So we have 2 samples. We're doing a test for P1 minus P2. Now let's get to the fun stuff, the do. We draw our curve. Remember, that's your insurance policy. You don't necessarily need to have it. With my curve here, I'm going to just get rid of this blue thing here. Okay, and I'm going to close the door. There's a couple weeds out there. Okay, so with this, with our curve, 0 always goes in the middle. That's your null hypothesis always, your assumed truth rate. Now, we're assuming that the mean of the distribution is 0, that the difference between them is 0, okay? Then we have our statistic. Now, one question that gets asked is, how do I know which side do I need to mark my statistic? You need to quickly compute it and see, is it a negative value or a positive value? So we're looking at the difference in the statistics. This 56 is describing the number of people at a heart attack. It's describing the sample. So 56 over 2051 minus 84 over 2031. Some of you can just see it in your head using math. You're good at math that way. Others of you might need to just quickly type it in your calculator to confirm that this statistic is a negative statistic, that difference, right? Okay. So I mark it here at arbitrary point, just use your judgment. So quick review, what do we have? We have 0, that's your null hypothesis always. Our statistic, what we observed happened. And now here's the tricky part, what you need to write down in your notes. When you have two samples and you're dealing with proportions, you have to combine the P's, P, C. You pool them together, okay? So you take the gemfibrozil group plus the placebo group, and you don't do normal math. You just add across. This is the combined rate, okay, of people who had heart attacks after 5 years. So out of the 4,082 people who participated in this study, 140 of them had heart attacks, okay? Make a note, you only do this for a test, okay? There's no formula on there that shows you that. And if you look at the formula sheet, they don't even tell you that it's a PC, okay? So you have to know that. You need to write that down. You do know it's a special case when P1 is equal to P2, so hopefully that can help you, that you know it's a test, but you can write it down this year for the year 2020 because it is an open book test. Okay, what do I do with that then? Once I combine them, I need to plug it into this formula, okay? So the P combined times 1 minus P combined, square root times the square root of 1 over N1 plus 1 over N2. So I filled that out for you to save some time, and you can see that right here. The line didn't go all the way over, so that's why I have that black line right there. And if that doesn't look nice to you, I can try to go like this for the top of that square root, if that helps. I don't know if it really does, but here's my standard deviation. So I'm going to mark that, right? And then finally, this is a two-sided test, which means it's a not equal to in your HA. So I'm going to mark that here. Relatively the same area if you think about it with calculus. Okay, it doesn't need to be perfect. Okay, and now the fun stuff. This is what the College Board's going to be testing. Can you show your work for that Z-score? So I have Z is equal to what I observed. I observed two statistics. I'm looking at the difference of them. That's right there, ZOMs. What I observed minus the mean of my distribution. That's the center of the curve. Divided by the standard deviation. I wrote it up here, so I do not need to write it again, okay? I find my Z-score by hand if you don't have a graphing calculator. Hopefully you do. Let's become one with our calculator, okay? So we go to, again, my daughter's outside, guys, forgive me. I go to stat. I arrow over to test. I go to 2-prop Z-test. Keep going. Did I miss it? Where did I miss it? Oh, I'm gonna calculate. Go over to test. Sorry, guys. 2-prop Z-test is number 6. Forgive me. Okay. I have it already typed in there for us. We're doing a not equals to, and we're gonna go ahead and we're gonna calculate. Okay, and I already brought the statistics over here, okay? So my Z-score is negative 2.47, okay? My p-value is where is it? It's right here, 0.0135, okay? And so I would want to write down that Z-score of negative 2.47. Now, if you don't have a calculator, a graphing calculator, you would hopefully find this by hand, so practice that. And then you would have to go to your table, okay? This is only if you don't have a graphing calculator. You go to your table and you find this p-value. You do not need to subtract from 1 because it is a negative Z-score. But then what you have to do is you have to multiply by 2 because it's a not equal to. It's a two-sided test. And you should get the p-value of 0.0135. Okay, if you don't get that, let me know. So now we look at we also want to write down our p-value. Okay. I'm not going to write it down because it looks so messy with just using my cursor, but you would want to write that down. My p-value is 0.0135. And because now here's what I'm at the conclude. When the p-value is low, reject the HO. Our p-value is very low, but our alpha is 0.01. So our p-value is greater than alpha. I fail to reject the null hypothesis. I have no evidence that there is a difference in the proportion of heart attacks for men after 5 years, like the ones in the study, in the Gemfibrozil group versus the placebo group. All right, guys, make sure, again, watch the video from yesterday if you need. Real quick, fun fact about a z-score, make sure you know how to interpret a z-score. A z-score is the exact standard deviations above or below the mean. Observation is, okay? Make sure you know how to interpret that p-value, that confidence interval. And lastly, fun fact about, was it my daughter today? Did I do my daughter yesterday? I can't remember. Fun fact about my daughter, Annika. She has red hair. It's very long, and she never wants to cut it. We only get it cut a couple times a year. I know it's not the healthiest to do that, but she loves it down all the way to her waist. I try to get it a little bit above that. So anyhow, you guys have a great night, great day. 21 minutes, clocking in better than yesterday. Tomorrow will be even better with that type 1, type 2. I think it's 12 minutes. So have a great day, you guys. Miss y'all.